Good morning, 7th grader. We'll continue with chemical transformations, and today we'll talk about chemical reactions and energy. The objective that we learn at the end of this video is distinguish between endothermic and exothermic reactions. Let's first recall back previous information. A chemical reaction can be detected by one of the following signs or evidences. Do you remember them? List them by yourself. Pause the video and list them. Good. The color changes. As you see here, we have colorless liquid that turns blue. A precipitate is formed, where we start from two colorless liquid to obtain yellow solid precipitated at the bottom. A gas is released in the form of bubbles, where some vinegar are added over a piece of chalk to observe bubbles. And the last one is energy is exchanged or temperature change, where we have some explosion and you can feel the heat that produced. And also we've studied that a chemical reaction can be represented by a chemical equation as follows, where I write the name of reactant 1, draw plus, which stands for the word reacts with, then the name of reactant 2 and on. Then draw an arrow that stands for the word give and write the name of the product, placing a plus between them. Let's also make an application. Observe the following experiment, then answer the questions that follow. Don't forget to pause the video before any question. Here we have, as you see in the speaker, an iron nail and a blue solution of copper sulfate. Few minutes later, they will give. Yes, what do they give? Good, look here, it's wonderful. What happens for the color? Do you see this color? Yes, it's a green solution of copper sulfate. And look here, what do we have on the iron nail? Look at the iron nail. Yes, it's red-brown layer of copper metal on it. Now, observe the experiment, the color and the deposition, and try to pick the evidences for the occurrence of this chemical reaction. Yes, mention two signs for the occurrence of the above chemical reaction. Yes, observe the experiment and try to pick them. Good. Change in color is the first one, where the blue color turns green, and formation of precipitation, red-brown layer of copper metal on the iron nail. Let's observe the experiment again, where I dip an iron nail in a blue solution of copper sulfate to obtain copper on the iron nail and a green solution of iron sulfate. Yes, now indicate in this reaction the reactants. Pause the video and try to define the word reactant and mention them, this experiment. What about the products? What are the products? The new obtained substances. Nice. Then the reactants are iron nail and copper sulfate. What about the products? The products are copper and iron sulfate. Now, represent the chemical reactions here. Could you write the word equation of the occurring chemical reaction? Yes, the word equation have some conditions. Plus between reactants, plus between products, arrow between reactants and products. Don't forget. Yes, pause the video and try by yourself. Good. It's copper sulfate plus, that stands for the word reacts with, iron, arrow that stands for to give, iron sulfate, plus that stands for and, copper. Nice. Now, one of the signs of the chemical reactions is the production of energy. Example, heat energy or thermal energy that you can feel upon burning some wood. Light energy or radiant energy that may produce from some chemical reaction. Electrical energy that's obvious in the bulb. Let's concern heat energy and study it. If you look here, the heat is produced upon burning some wood. And in this chemical reaction, where we add hydrochloric acid over zinc powdered. Yes, in your opinion, what happens for the energy here? Let's observe the thermometer. Yes, look at the temperature. What happens? Good, it's increasing. Now, do these reactions release heat energy? And do all reactions release heat energy? Let's discover. In chemical reactions, heat energy is either released or absorbed during these chemical reactions. In a chemical reaction, then, it's accompanied by releasing of energy, and here it's known as exothermic reaction. Spell it with me. Exothermic reaction. While in some chemical reactions, the energy is absorbed, and it's known as endothermic reaction. Repeat it. Endothermic reaction. Let's start with exothermic reaction, where the word exothermic is of two parts. Exo, that stands for the word exit, and thermic is derived from the word thermal or heat energy. Then, exothermic reaction means reaction where heat is exit. Let's observe this figure where we are burning some wood and you are sitting beside it. What do you feel? You feel warm. From where is this temperature coming? From the reaction. Then the reaction gives energy to its surrounding. So heat energy is transferred to the surrounding. This indicates that heat energy is released. And what happens for the temperature during an exothermic reaction? Observe the thermometer. Yes, what happens? Do you see? It's increasing as you see. Nice. Then, as a sequence, the temperature of the surrounding increases. Let's now discover endothermic reaction. Also, the word endothermic is of two parts. Endo and thermic. The word endo stands for the word entrance, and the word thermic for the word heat. Then, it's a reaction where heat enters to it. Now, let's observe this figure. We are cooking some egg. We need energy or heat for this chemical reaction to take place, for the reactants to react together. We need energy. Then the reactants take this energy. Then the reactant absorb the heat energy or the thermal energy. Then heat energy is taken in from the surrounding, and this indicates that heat energy is absorbed. Let's discover the temperature. How does the temperature change during the endothermic reaction? Observe the thermometer. Yes, do you see the thermometer? Heat in the thermometer. What happens? It's decreasing. You are wonderful. Then the temperature of the surrounding decreases. Good. Observe this chemical reaction where the heat is released. We have in the speaker some hydrochloric acid. I place it in the Erlenmeyer flask. Put just above it some zinc powder. Do you see? Place a thermometer. Do you see the bubble that indicate the occurrence of a chemical reaction? Look at the temperature. The initial temperature was 20 degrees Celsius. What happens for this temperature? Let's observe the thermometer again, please. Yes, look at the thermometer. What happens with, it's increasing by itself. I didn't place it on a fire. It increases by itself. Look. Yes, it's still increasing. It reaches 44. Yes, 45. And it's still increasing. It's wonderful. Till it reach, what is the final temperature that it would reach? Wonderful! It will reach 50 degrees Celsius. Now, let's answer some questions and don't forget to pause the video. What evidence showed that a chemical reaction taking place? Yes, look here. What are these? And remember the video? Good! Release of gas in the form of bubbles, or we can say production of heat energy when the temperature increases by itself. Name the reactants used in this reaction. Yes, reactants, the starting materials. What are they? Wonderful. Zinc and hydrochloric acid. You are wonderful. Now, let's observe the thermometer and recall back the temperature. Now, mention the initial temperature, the temperature that we started from. Do you remember it? It was approximately 21 degrees Celsius. What about the final temperature? Let's look at the thermometer again. It increases till it reaches, nice, approximately 50 degrees Celsius. Then give one word to explain the variation of the temperature here. It's increasing. Wonderful. Now, compare temperature T1 to temperature T2. And don't forget the conditions of comparison, where you have to write a complete statement. You have to mention the values and the units if they exist, and the correct term of comparison. Less than, smaller than, wide, greater than, etc. Yes, make a comparison by yourself. Pause the video. Good! At the beginning of the experiment, the temperature T1 is 21 degrees Celsius, you see, less than. That at the end of the experiment, T2, which is 50 degrees Celsius, you see. Now, let's observe the experiment again and answer the experiment accompanied by release or an absorption of heat. You think what happens for the temperature in this experiment? It starts from 21 degrees to reach 50 degrees Celsius. Good! Accompanied with a release of heat, where the temperature increases from 21 degrees Celsius to 50 degrees Celsius. So, in this experiment, the temperature is increasing and it gives some heat for the surrounding. Yes, then indicate the nature of this chemical reaction. Is it endothermic or exothermic in your opinion? For the video, good! The reaction is exothermic. You are wonderful. Now, the obtained products are zinc, chloride, and hydrogen gas. Let's try to write the word equation of the chemical reaction taking place. And don't forget, plus between reactants, arrow, plus between the name of the products. Pause the video and try by yourself. Yes? Good! It's zinc plus hydrochloric acid, arrow, zinc chloride plus hydrogen gas. But how could we infer that? Hydrogen gas is produced. How can we identify its presence? Observe this video where we have here hydrogen gas trapped inside a test tube. Yes, open the test tube and approach a flame. Look, what did you hear? I said, pop sound. That's right. Then it will give pop sound in the presence of a flame. This is a hydrogen gas. Let's take another example that shows a reaction which absorbs heat, where we start here from barium hydroxide. I'll put some grams of barium hydroxide inside the first beaker, as you see here. On the other beaker, what we put in your opinion? Good, we put ammonium chloride. It's also a powdered solid, as you see. And before we mix them together, I place the barium hydroxide over a piece of wood that has some water on it and check its temperature. Let's check the initial temperature here. The starting temperature is 23.9 degrees Celsius, as you see. We mix them together, barium hydroxide with ammonium chloride. Upon mixing them together, we'll observe the temperature. What happens with the temperature? Let's check. Going back to the digital thermometer and observe the temperature again while mixing them. As you see, yes, what happens? Oh, the temperature is decreasing. Oh my God, it reached minus 2.5 degrees Celsius. Then what are the reactants in this reaction? Yes, what are them? Starting materials? Good. They are barium hydroxide and ammonium chloride. Let's go and mention the initial temperature. Yes, observe the thermometer. What was the initial temperature? It was 23.9 degrees Celsius. Let's check the final temperature. Observe the thermometer again. What happens to this temperature? It's dropping down till it reaches minus 2.5 degrees Celsius. Then could you give me one word to describe this variation? Good, it's decreasing. The temperature is decreasing. Now, compare temperature to T1 to T2. Don't forget, yes, the temperature T1 is 23.9 degrees Celsius. Greater than that at the end of the experiment T2, which is minus 2.5 degrees Celsius. Then the temperature is decreasing by itself. Is this reaction, in your opinion, accompanied with release or an absorption of heat? Do the reactants here need heat from the surrounding to decrease the surrounding temperature or give heat? Good. It's accompanied with an absorption of heat. The temperature decreases from 23.9 degrees Celsius to minus 2.5 degrees Celsius. Then it's absorption of heat. So what is the nature of this chemical reaction? Think, exo or endothermic? Good! The reaction is endothermic reaction. As a summary, most reactions involve the absorption or release of heat. Now, we classify them as exothermic reactions or endothermic reactions. The exothermic reactions where the reactants produce heat to obtain the product, and this production of heat will be released to its surrounding, where the reactants get hotter than the surrounding, so it gives the surrounding some of its heat. So, a reaction accompanied with the release of heat is called an exothermic reaction. There is a rise in temperature. Why? Endothermic reaction. The reactants need heat energy. It absorbs the heat from the surrounding in order to produce the products. So the reactants are cooler than the surrounding. So it absorbs heat from the surrounding to take place and to produce the products. Then a chemical reaction accompanied with the absorption of heat is called an endothermic reaction. There's a drop in temperature. Now, let's make an application. Application 2. Indicate in each case whether the reaction is exothermic, where heat is released or increasing temperature, or endothermic, where heat is absorbed or temperature decreases. Let's check for the first picture, where I have photosynthesis reaction taking place. The green plant absorbs the energy from the sun. Yes, what is this? Think, both of it, you think. What is it? Absorbing of energy? Good! It's endothermic reaction. Let's take another example. Again, where we have a reaction here between a substance at the beginning, what temperature was 20 degrees Celsius. At the end of the reaction, it becomes 45 degrees Celsius. Here, the reaction between these two substances, starting from 20 degrees Celsius to 45, the temperature is increasing by itself. Then what do we call it? You think. Both of it, you think. Yes, it's exothermic reaction. You are wonderful. Good. Nice. Let's also continue. We are going to decompose some sugar here. But the sugar couldn't decompose by itself. We need a heat source. We have to place it on a Bunsen burner where the sugar needs energy, absorbs energy to decompose. Then pause the video and think, is it exo or endo? Good! It's endothermic reaction. You are wonderful. Let's continue. Where here I have a combustion of the butane gas in a Bunsen burner. Look at the wonderful color of the butane. The butane gas gives a blue flame upon reaction with oxygen. It gives us heat. If I approach it, then it's exo or endo in your opinion. Pause the video and think. Good! It's exothermic reaction.